All right, even functions. The graph is symmetric with respect to the y-axis. All points x, y also have the point negative x, y. Odd functions means the graph is symmetric with respect to the origin. So x, y also has the point negative x, negative y. Good. The way that you test for them is if it's an even function, you should be able to make all the x's negative and end up with the exact same equation as if the x's were positive. If it's an odd function, you should be able to make all of the x's negative, and that will turn into the entire function being negative. Don't worry, we will practice this. So if you're just looking at a picture of the graph for these three examples, is the graph an even function, an odd function, or neither even nor odd? Okay, so let's look at that first. I should label them. Let's look at A. Okay, so remember, is this the graph of an even function, an odd function, or a function that is neither even nor odd? And if we look at this, oh, sorry, I didn't pin myself. Okay, so remember, you're talking about a function, and so what is the rule of a function? It has to pass the vertical line test. Letter A does not even pass the vertical line test, so we would say that this is neither even nor odd because it's not even a function. All right. Letter B, is it symmetric with respect to the y-axis? Meaning, if we folded it along the y-axis, would this side of the graph be on top of this side of the graph? Or if it's an odd function, it's symmetric with respect to the origin, which means if I turned it all the way upside down, I have the exact same graph. Okay, so think about, of those two choices, if you are just looking at the picture, is this an even function, meaning it is mirrored along the y-axis, or is it an odd function, meaning it is the same when I turn it upside down? Hold on, guys, sorry. That's completely fine. I understand. Thank you for coming. And oh, I'm sorry. Just tell everybody in that room that they don't have to stay if they don't have computers, and they can watch this video because I'm recording it. I will not take attendance today. So anybody who needs to leave can go, because if you don't have a proctor, I can't take attendance. Bye, guys. Have a good weekend if you do have to leave. All right. So did we decide? Have we thought about it? So remember, would the graph lie on top of itself if I folded it along the y-axis? I think that that's true for B, right? Or you can kind of think of, this is probably the point negative 2x, 2y, right? And then am I mirroring that over here with a positive 2x, positive 2y, right? For every point xy, we have the point negative xy. Here's xy, here's negative xy. Maybe here's negative 3, 0, here's positive 3, 0. So I'm able to mirror every point across the y-axis. So I'm going to call this an even function. I can fold it in half right here, and I can mirror each point. Good. Letter C, if it is odd, remember, symmetric with respect to the origin means it looks like this now. If I completely turn it upside down, it still looks like that. All right. So a good way to determine whether it looks the same upside down is you can draw it on a different piece of paper, right? You'd be like, okay, this graph looks like this through the origin. And then if I turn it upside down, oh, it still looks like that one I drew of it. Yeah. Or you can just kind of describe it to yourself. You can say it opens, the left-hand side is below the x-axis, it crosses right at the origin, the right-hand side is above the x-axis, and it goes on forever in both directions. And then if you turn it upside down, is that still an accurate description? The left-hand side is below the x-axis, it crosses at the origin, and the right-hand side is above the x-axis. Good. If that's still true, then that would be symmetric with respect to the origin or an odd function. Good. You can also, we can pick a point. All right, we'll pick the point. Maybe that's 5x 2y, right? If I have the point xy, then the point -5, -2 should also be on the graph, and it is. So I'm going to call this one odd based on these rules. All right. Neither, because it's not even a function. Even, because each point I can match with the same point with a -x. And then odd, because each point has its opposite also on the graph. Now, for example 2, determine whether it is even, odd, or neither. We are not looking at the graph. You can put it into Desmos. Remember, you can always put everything into Desmos. But if they just give us the math, remember the rule, okay? What we're going to do f of -x equals f of x, it's even. F of -x equals -f of x if it's odd. All right, so you're going to change x to f of x. Change x. Did I say f of x or -x? Because I meant to say -x, and I'm doubting now what I actually said. Everywhere you see x, change it to -x. If it is back to the same equation, it's an even function. If it becomes the negative of the original equation, it's an odd function. And if it doesn't fit either, it's neither. Good. So let's write that down. If it is even, if it is an even function, what will happen is the f of -x will become f of x when I simplify it. If it is odd, when I change x to -x, I will get negative f of x as my simplified answer. All right. So for each of these 4 examples, we're going to take that x squared right there, it's going to become a -x squared. That x cubed is going to become a -x cubed. That x squared is going to become a -x squared. All right. So that's what we're doing. Let's look at A. F of x is 2x squared plus 3. Change x. Oh, sorry, hold on. No worries. Bye. See you Monday. All right. F of x equals 2x squared plus 3. Change x to a -x. Now it becomes 2 times -x squared plus 3. All right. Remember, -x squared becomes, -x times -x. A negative times a negative becomes a positive, so that is re-simplified back to x squared. You see how I did that? So you're basically deciding, does this -x, does it matter whether this x is a negative or a positive? Will a -x give me the same answer as a positive x in this situation? If so, it is even, right? We're back to f of x. If it's, let me explain it a little better. If it's even, that means it should look like 2x squared plus 3, right? If it's odd, it's going to look like a negative. All of that becoming negative. So negative 2x squared plus 3, which becomes negative 2x squared minus 3, right? Even it stays the same, odd it becomes a negative of everything. So we changed the x's to negative x's, we got even. So A is even. B, we have g of x equals x cubed plus 3. Okay, let's talk about what it looks like if it's even. So if it's even, we are back to the original, x cubed plus 3. If it's odd, we have negative x cubed plus 3 or negative x cubed minus 3. If it's neither of those, you just say it's neither. Good. So you take your original, switch in a negative x for the x. So now it's a negative x cubed plus 3. Negative x cubed, remember, means negative x times a negative x times negative x. When we take a negative times a negative, it becomes a positive, but a positive times a negative becomes a negative again. So that's x squared times negative x plus 3, which is negative x cubed plus 3. Good. That does not look like the even graph, and it does not look like the odd graph, so we have to say that this is neither. C is h of x is equal to x cubed plus 4x. All right, if it is even, it will look the same, x cubed plus 4x. If it is odd, it will become negative x cubed plus 4x, which is negative x cubed minus 4x, right? Okay, thanks for telling me. I will remember to upload the video. All right, so remember, we're taking that x, we're changing it to a negative x. Negative x cubed plus 4 times negative x. Anywhere you have an x, put in a negative x. Negative x cubed, we know, remains negative x cubed. Positive 4 times a negative x is a negative 4x. Good. So that is odd. That matches. When I put in a negative sign, a negative x for x, I make it is equal to making the entire equation negative. Good. Last one. Sorry, I'm very sideways. F of x is 1 over x squared plus 8. If it is even, I should end up with the same thing, 1 over x squared plus 8. If it is odd, I should end up with negative 1 over x squared plus 8, right? Oh, everybody's leaving. That's okay. I understand. Good. All right, so I'm going to replace the x squared with negative x squared. Remember, negative x squared, let's look up here. Negative x squared is the same as x squared. So I know that 1 over negative x squared plus 8 is going to be the same as 1 over x squared plus 8. So I know that that is even. Okay. Let me pause this real quick. We said that a 2x squared plus 3 is even. That means it is symmetric with respect to the y-axis. If we look at it, that looks symmetric with respect to the y-axis. Good. B, which was x cubed plus 3, we said is neither even nor odd, so it will not be symmetric with respect to the y-axis or the origin, and that's because it's raised up too high, right? If it went right through the origin instead of through positive 3, then it would be odd, but because it's has the plus 3, it's neither even nor odd. X cubed plus 4x, we said that that is odd. And if we zoom out on that, it does look like if we turn it upside down, it would look the same. And then the last one, we said that this one's even, so it should mirror itself along the y-axis. Ooh. Can't tell what it's doing at all, but it does mirror itself. All right, so those are our answers. And we were able to check them with a graphing calculator. Now let's talk about increasing, decreasing, and constant functions. When you see this, just think slope, okay? A function f is increasing. Sorry, I'm gonna write it. We're thinking of slope here. A function is increasing on an interval if the graph continuously rises from left to right on the entire interval. So this is, the hardest part of this is just marking intervals, understanding intervals, and how to write intervals, okay? So you're just talking about the space between x1 and x2, between x1 and x2, between x1 and x2. Good? So this is f of x between x1 and x2. Here's f of x between x1 and x2. Here's f of x between x1 and x2. Again, it's increasing if it rises from left to right or has a positive slope. Good. So increasing means it has a positive slope. Obviously, decreasing means it has a negative slope. And then constant means it has a zero slope. We're not saying positive slope, negative slope, and zero slope because there is something else they're going to ask us about functions. Where is it? All right. Increasing, decreasing, constant, positive, and negative. All right. So we don't say it's a positive slope because when they say positive, they mean above the x-axis. When they say negative, they mean below the x-axis. And so increasing is a positive slope, but we don't say positive, okay? So increasing is a positive slope. And I know I'm rushing ahead. I'll go back. And decreasing is a negative slope. So just if you are thinking of them as slope, like I'm telling you to, I guess, make sure that you're not confusing increasing with positive, decreasing with negative. Those are different things that they're asking. All right. So this is an example of a function increasing from over the interval. Okay, so they're saying from f of x sub 1 to f of x sub 2. How do you write that? The way you write that is just like interval notation, okay? It's increasing on an interval, so think interval notation. Between x1 and x2, we are increasing. Between x1 and x2, we are decreasing. And here between x sub 1 and x sub 2, we are constant. So example 3 asks us to determine the intervals for which the function is increasing, decreasing, constant, positive, and negative. Okay, those are all different things, so let's mark them. Increasing means it has a positive slope. Good. Increasing. Where is it? Where does it have a positive slope? All right, and then it wants to know where is it decreasing? Where does it have a negative slope? Okay, so you can look at here, we have a function. The function begins at -2. Here we begin at negative, oh, sorry, -4. It's important to point that out, I guess. So we're beginning at -4. Our interval ends at +4 because we're looking at it according to the x-axis. Okay, so when you're writing intervals, you're writing according to the x-axis. From x1 to x2, we're increasing. From x sub 1 to x2 sub 2, we're decreasing. From x sub 1 to x sub 2, we're constant. So where are we increasing? Good. Increasing looks like this. You can look at your graph. Between -4 and -2, we are constant, right? From -2 to 0, we're increasing. And from 3 to 4, we are increasing, right? And this is how we write it. You always have the brackets because between x1, x sub 1, and the next point, you are increasing, okay? So increasing and decreasing always get brackets, never parentheses. So I'm going to say increasing. What did I write? I wrote that it began increasing at -2 and stopped increasing at 0. And then again at +3, does everybody see how I got +3? And ending at +4, it's increasing again. So on the x-axis from -2 to 0, it's going up. And then from 3 to 4, it's going up. Okay, so that's where it's increasing. Now let's talk about decreasing. Decreasing means it's just going down, right? Just like this picture, we're decreasing. So decreasing is from here to here. We are only writing it along in terms of the x-axis. So we begin decreasing at 0 on the x-axis from 0 to 3. Good. Finally, we have constant. Constant just means you're flat. So if it starts at -4, that means from -4 to -2, it was constant. Any questions? All right, so that was increasing, decreasing, and constant, but we also have positive, meaning above the x-axis, and we have negative, meaning below the x-axis. Good. -4 to -2, it was on the x-axis, right? But where is it above the x-axis? From -2 to +2, we are above the x-axis. Good, so I'm going to say I am positive from -2 to +2. These get parentheses because we're not including -2 and +2. Those are at 0, right? We know that -2 is at 0 and +2 is at 0. Think about, so here's my x-axis. If I'm on my x-axis, I'm at x equals 0. Okay. If I am above my x-axis, I am positive. If I am below my x-axis, I am negative. But as long as I am on the x-axis at -2, 0 and 2, 0, I am not positive or negative. I'm 0. Good. And finally, oops, negative. I am below, right? I am below the x-axis between 2 and 4. Not including 2 or 4. There's a lot going on. Make sure you know, feel comfortable with that. A function has a local maximum value at any point that is higher than all the other points around it, or the top of any hill is a local maximum. Okay. A local minimum is the bottom of any valley. Okay, so something else that they're going to ask us about functions when we're describing functions is to find local maximum and local minimum. Okay, if you have a hollowed out point that is not, the empty circle is not included on the graph. Of the function, so not a part of the function. Okay. That point is included because it's filled in. These points are not included because they are hollow, not on the graph. Good. So here is my local maximum, C, comma, f of C. C is my x, f of C is my y. That's my local maximum because it's the top of a hill. All right, my local minimum, written the same way, C, comma, f of C, because it's the lowest point, or it's the bottom of any valley. It's not the lowest point on the entire graph, but everything around it is above it, right? It's the lowest point in that area. Goes down, comes back up, goes up, comes back down. Good. Higher than the other points around it, so goes up, comes back down. Here goes, what do you think? Down, comes back up. Good. All right, those are local maximum and minimum. Then, after example 4, we're going to talk about absolute maximum and minimum, okay? Absolute maximum and minimum is the highest. Absolute maximum is the highest. Absolute minimum is the lowest. All right, so here's my absolute maximum. Good. Here's my absolute minimum. Higher than all the other points, lower than all the other points. Lowest point on the graph. Good. These are also your local minimum and your local maximum. You can just have more than one local maximum and local minimum on your graph. Absolute minimum and local minimum, absolute maximum and local maximum. The highest point and the lowest point, there's only going to be one, right? But local max and local minimum are any hills or any values. Okay, values. Any hills, any valleys. If it goes up and comes back down, that's a local maximum. If it goes down and comes back up, that's a local minimum. Not if it's a hollowed out one, though. Only if it's colored in. So example 4, it says locate any local max values. Good. So if it goes up and back down, it's a local max. 0, 3 is a local maximum. Okay. There are 3 ways they might ask you to write it. The local maxima is f of x equals y, right? Because my x is 0, my y is 3. Or my local maxima is at x equals 0 and is 3. At x equals 0, my local maxima is 3. Okay. This is all saying the same thing. This is the same answer. Just different ways to write it. All right. Local minimum, there are 2, right? So this is my local maximum. My local minimum is -2, -1, was it? Because it goes down and comes back up. And then 1, 0. So is f of -2 equals -1, or at x equals -2 is -1? And my other minimum is 1, 0. Is f of 1 equals 0, or is at x equals 1 is 0? Good. So those are your local max. It's just this one. Your local minimum were both of these. And so there were 3 different ways to write it. All right. And then finally, it says, where is f increasing and where is f decreasing? Remember, that's not positive and negative is above or below the x-axis. Increasing and decreasing are just up and down, right? Positive or negative slope. Increasing slope from here and here, right? Decreasing slope here and here. Okay. Notice that this is an arrow. This is the first time we're seeing arrows when we're having to describe increasing and decreasing. So it's going to be, the arrow's going up, but we're always reading from left to right. So you're reading this like you're reading a book, right? Look at any local max values, keep reading, right? So when I read, I see that this is actually decreasing, right? So it's decreasing from negative infinity until it gets to -2, right? It's including -2, but we never include infinity, so that always has a parentheses. And then it starts decreasing again between 0 and +1, right? So from here to here, it's also decreasing. Remember, decreasing and increasing, unless it's an infinity, they always get the brackets because you can always take a tiny, tiny, tiny number before this one, or sorry, right after this one, I should say, and it will be going down, right? The difference between this and the number next to it is a decrease. So it always does include. And that's why we have brackets. It always does include the term closest to it. And then increasing. So as I read from left to right or walk across the graph from left to right, it begins increasing at -2 and stops increasing at 0. And then it begins increasing at 1 and goes forever. It can be both decreasing and increasing at 1 at the same time, right? From this term to this term, it's going down. From this term to this term, it's going up. That's what they mean. So we covered local maximum and minimum, absolute maximum and minimum. Here is U, comma, f of U is my absolute maximum. V, comma, f of V is my absolute minimum and my local minimum. Now it says find any absolute and local max and minimum values. Remember, sorry, I'm losing my voice. Remember that if it's hollowed out, that is not on the graph. That point is not on the graph. That point is not on the graph. Oh, I'm sorry, I couldn't see that. I'm not saying X. Darn it. I'm saying it's not on the graph. I don't know how to make that clear. Not a point on the graph. So let's look at A. Remember, 3 is my X, 6 is my Y, 1 is my X, 3 is my Y, 5 is my X, 2 is my Y, right? Absolute and local max and minimum values. So for graph A, my local max is anywhere that I have a hill. It comes up and goes back down. So I'm going to say X equals 3 at 6. It's the one time it goes up and comes back down. Okay. Local minimum. Is there anywhere it goes down and comes back up? Yes. X equals 1 at 3. Now, absolute maximum, the highest point on the graph. It could be your local max or it could be somewhere else. It's the same. X is 3 at 6 because that's the highest point on the graph. And there's only going to be 1. Absolute minimum. What's my lowest point on the graph? It's going to be 5 at 2. Because 2 is the lowest that Y gets. Y is 4, Y is 3, Y is 6, Y is 2. Y is 2 is the lowest. All right, next one. We have this guy, but 2, 6 is excluded from our graph because it is not a filled in circle. It is an open circle. So we don't have, sorry, we should look at it. We don't have a local maximum. We don't know what the point is that is included in the graph that's actually higher than any other point in the graph. So we say none. Local minimum. There are points that become low on the graph, but none of them go down and come back up. It has to be a valley, go down and come back up. So there are none. Absolute max. This is my highest point, but it's not included in the graph. So I don't have enough information. So I just have to say none again. I can find my absolute minimum. So the only term I can find for B is my absolute minimum. Y is 3, Y is 4, Y is 6. The lowest is Y equals 3, right? So it's at X is 1 at positive 3 for B. Here's my graph of C. My local max would require it to come up and go back down. There's none. Local minimum, it has to be a valley. There is no valley. There's nowhere it goes down and comes back up. Okay. It would have to be much more like that, not just down low for a long time, comes back up. So there's no local minimums or maximums. Absolute maximum for C is going to be at 6, 3, right? X equals 6 at 3 is my highest point. and my minimum, there is no point that is lower than all the other points on the graph. So we do not have one of those either. Letter D, we just have a function that starts at x equals 0 and goes down forever. So there are no hills, there are no valleys. Without hills or valleys, we can't have local maximums or minimums. Absolute maximum, we know it, because this is going down forever, but it's not going any higher. So absolute max, remember you say x is 0 at 6, but absolute minimum, because there's an arrow, we say there's no absolute minimum. It goes on to negative infinity. All right, let's look at E. Letter E is interesting. Are there any hills? There is one hill at 3,5, but 3,5 is excluded. So we have to say there is no local maximum. Local minimum. This does not come back up, so this is not a local minimum. 5,3 is my local minimum. So it's x equals 5 at 3. My absolute maximum. You see this? This is an arrow, so I don't have an absolute maximum. Absolute minimum. I know it's close to 2,2. I know it's not 2,2, but I don't know what it is, so I can say none. So there are many reasons why you cannot find the information they ask you to find. Be confident when you say none. Good. Last thing. Oh, we might have time. All right, average rate of change. The average rate of change between 2 points on the graph of a function is the slope of the linear line between those 2 points. So you're trying to find the average. We know it's not the exact, it's not the exact slope of the line because this line is not a straight line, right? If we look at this line, that's not a straight line, but rate of change is slope. When we are trying to find the rate of change, we are averaging it by making a straight line. We don't know what the slope is of that curve, but I can just make that line straight. I can make that line straight, and I can make that line straight. And those are all average rates of change. Good. All right. If we think about a line being drawn between those 2 points on the function, what would the slope of that line be? The average rate of change between 2 points on the graph of a function is the slope of the linear straight line between the 2 points. M equals y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So exact same slope formula that we used in previous units. Good. So here is f of x equals x squared plus 1. They want the rate of change from 0 to 1. So from x equals 0 to x equals 1, right? So when x equals 0, y equals 1. When x equals 1, y equals 2, right? So my x1 is 0, y1 is 1, x2 is 1, y sub 2 is 2. Is that okay? I just took those 2 points and labeled them. This is my first one, so it gets the sub 1. This is my second one, so it gets the sub 2. And then I put them into that equation. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1 is 2 minus 1 over 1 minus 0, right? 2 minus 1 is 1, 1 minus 0 is 1. So we have a slope of 1 between x is 1, between x is 0 and x is 1. This has a slope of 1 when we just draw a line. Good. B wants to know the slope from x equals 1 to x equals 2. The point at x equals 1 we know is 1 comma 2. At x equals 2, we go all the way up to 5, right? So m is, this is x1, y1, x2, y2. M is 5 minus 2 over 2 minus 1. 5 minus 2 is 3. 2 minus 1 is 1, right? So my slope is 3 right here. Between that point and that point, it's 3. And then the last one is from 0 to 2. So it's going to be that line. From x is 0 to x is 2. That point is 2, 5, we know. And that point is 0, 1. So we're going to say, oh, sorry, I couldn't even see that. 5 minus 1 over 2 minus 0 is 4 over 2. 4 divided by 2 is just 2, right? So this slope is 2. So depending on how close you choose the points or how far away they are, will be how accurate your average rate of change is. But basically, you're just taking the x and y values of the 2 points, putting them into the slope equation and finding the slope and calling it the rate of change. Good. So we covered, is a graph even, odd, or neither based on its symmetry, based on changing f of x to f of negative x and simplifying. Is a graph increasing, decreasing, constant? Is it positive or negative? Can you find local maximums, local minimums, absolute maximums, absolute minimums, and then finding the rate of change, which was a lot.